Hello, I'm JW, and this time with the CNC machine we'll be fitting the stepper motors and also the spindle motor, wiring those things up and hopefully getting those motors actually working so we can see the spindle thing rotate and obviously the axes and things moving. And of course that will also involve some wiring inside the cabinet as well, so we'll have a look at all of those things. Right, this is the end of the Y actual spindle here, but they're all basically the same. And this is the coupler here, which comes in 3 parts. So we've got 2 of these aluminium pieces. One goes over each spindle, one here, one on the actual motor itself. And then there's this plastic piece here, which actually goes between. And the idea of these is it gives it a small amount of flexibility, so that if these are not perfectly lined up, then it can obviously still connect correctly. You can get these made out of solid metal, but the problem with those is you've got to then align the 2 spindles perfectly, which in reality is next to impossible. And there is another kind as well, which is made out of solid metal, but it's sort of like a spiral effect. But we've got these ones here, as the spiral effect one looked a bit fragile and likely to unwind themselves. But the principle is fairly straightforward. That goes over the spindle of the machine, and then the motor spindle again fits in the end like that. These clamp down with the little screws here, and then obviously this will then transmit this turning force through to the machine. Now to fix the actual motor, what we've got are some of these. So it's basically a bolt there which goes through the motor, and then a tube which is aluminium. Now the machine did actually come with some of these, but they turned out to be too short. These motors have quite long spindles, so obviously the ones that those supplied with were for was motors with much shorter spindles, so just got some longer ones and cut some piece of aluminium tubing there to a slightly longer length, and fairly straightforward. In the case of this one, we're going to have the wire coming out the bottom, so this goes through the hole in the motor and then just thread into the hole on the side of the machine. This tube goes over here, and that provides a spacing, so when you tighten this down it creates the correct spacing. Otherwise it would just sort of pull it in further and further and obviously not work correctly. So there's 4 of those, one at each corner, and that just goes in like that. Now you can use sort of like a hexagonal key thing to go in there, but a much easier option is one of these, which is just basically a handle with the hexagonal end like that, so you can also get the turning force going in somewhat more easily. So that essentially goes in like that, and then it's basically the same for the others. So again, the screw goes through the top hole like that, the spacer piece goes in the middle, and again just tighten that up from the side. So that's that all attached there, just the 4 on each corner. And this is basically just slides together like that, so when we're finished we'll just slide that fully in, tighten those down, and then that will of course turn when the motor turns as well. But so for the moment we're going to leave that pulled back so we can obviously move this without having to move the motor as well. Here's a view of the others. So this is one just attached. The one over that side is the same, and so these don't actually move themselves. Of course they do rotate, but the actual things are fixed, so the wires just come along the bottom here, and this one will obviously attach in here later. The others here on the actual gantry, which of course does move, so I've got one on the end here, and again the wires just come along to the bottom, and the Z-axis on the top here. These have to move, so I've got these plastic tracks here, so as this moves across, just turn that one, and you see that the cables obviously just move along and flex as appropriate. And I've got the motor wire there. This one is for the spindle power, which just goes over the top there. These 2 are for the limit switches for the Z-axis, which are not yet connected. And on the back here I've got a junction box here, which again is for the limit switches, so single cable from the main controller, and that will just split off into the 4 switches we've got here, so 2 here for the Z-axis and then 2 here for the X-axis, so 1 at each end. So it's a bit tighter than trying to have obviously all 4 cables going back to the controller, and there's not really any point anyhow because ultimately they're all wired together. And the other limit switches will go on the fixed part of the frame here, so again they don't have to obviously move with the rest of the equipment. Now this is the spindle holder, basically just goes through there. These clamp down to secure it in place, came with the spindle. And this plate here, which is part of the machine, as you can see, is somewhat narrower than the actual holder itself, so I've had to make this adapter plate, just a 1/4 inch aluminium, and just put some holes here on the sides just to bolt these through onto the plate itself. And then we've got 2 more holes at the top and 2 at the bottom here, which will go into these holes I've actually added in the front of this plate. So essentially this will just bolt on the front like that. And then this here is the actual power for the spindle, so that just goes in the little plug on the top, and then this will actually move up and down on this flexible track thing as required. Now this did actually come with a mounting thing. It was a little tiny piece down here at the bottom, obviously designed for a much smaller spindle, and it was only a hold, literally they were just a ring, so it wouldn't have been desperately secure in any case. But yeah, just a minor issue there. And then this one, of course, the centre body is basically the width of this plate, and then the ears where it screws through, of course, overlap. So just put a sort of conversion or adapter plate thing on the back there. Now I didn't actually record making these holes because, of course, here you only get one chance to get it right without drilling through something in the back and destroying the place. But essentially it's these sort of cap screw things, as is used with the rest of the machine. These are stainless steel. 2 holes here which are sized so that these will just pass straight through, so sort of clearance holes. And then in here, just drilled out the holes and then threaded those with a tap so that then these can screw in here and obviously tighten down. And the same with the 2 here at the bottom as well. So now we've got this here. These holes here I've made slightly large so this can have some adjustment so that when it's all assembled we can get the thing absolutely vertical. Because of course we don't know exactly how well aligned that is, and obviously this and the adapter plate and so on, so some adjustment can be needed to get this sort of in the correct vertical alignment. And then for the alignment in the other direction, sort of like that, then if it proves to be correct then that's fine, but if not we can just undo one or more of these, just put a thin metal shim or something behind to get the correct angle as required. But so we won't know that until it's all fully assembled. So essentially these go through here and then just go into these holes here, which are threaded before, and then this goes in here. And then there's just 2 more of these which go underneath in the holes at the bottom. We can't see those on the camera, but same idea as at the top. Here's a look at the side track of the machine. I've put this plastic box here, just cables go through. Most of these just pass straight through, and the only ones in here are for the limit switches. Again, this is so you can just have a single cable from the cabinet, which is this one for limit switches. And then we've got this one which goes along here and up onto the top here, and then to that box which we saw earlier on the back. And the point of that is then we only have one limit switch and emergency stop cable going back to the machine, otherwise we'd have to have a huge extra fat bundle of at least another 6 of those. Of course it's pretty inconvenient and also completely unnecessary. So those will join in here, and then we're going to have the other limit switches for this axis here, probably on this end and the other end over this side. And again we can just bring those through the hole or put an extra hole in if necessary. And the other 2 emergency stops, this is one of them, will probably go on the front or somewhere here and probably over the other end as well. And again we'll wire those into this same signal cable here, multiple cores obviously. And again that just means we have the 1 cable going back to the machine, and there's 6 in total. I've already tied those together, as you can see there. And the deal with these things on the side is that these are flexible, but they don't move very much in this direction, so they keep it fairly rigid, so that when things move these don't sort of flop around and get tangled up in the mechanism and whatever. So if this moves, then you see these things will just curve around as appropriate and therefore not get all tangled around in various bits of moving parts. Here's the wires, I've just put them through those holes on the side there. So we've got this one which is for the spindle, that's obviously much shorter, let's just go into the spindle inverter just here. This one is for the limits and the emergency stop. That will just go to the little board in the middle here, which is not yet installed. It comes across like that. And then the other 4 here are for the stepper motors, so one for each of the motors, and those will actually go to the individual drives here, so the X, Y, Z, and then the additional one for the Y axis as well. So here's the wires that come in the side of the cabinet, and I've just exposed a short section of the braid there, and then just put another piece of braid across all 6 of those, and then basically attached it to the nut on the back panel, so those are effectively connected to the metal cabinet. Here's the board installed in the cabinet, and have a look there, it's the 2 boards, the sort of breakout board on the bottom and the motion controller on the top there, and just those 3 short ribbon type cables joining the 2 together. And I've got the motors and things attached here. Those are the connections on the left there, the purple and green, and also those orange ones. Power for this board comes in at the top left there, the grey and orange, it's just 24 volts DC. And on this side, just got a couple of things connected, which is essentially the emergency stop buttons, or rather the contact from the contactor, and also the limit switches. Now I haven't actually put the limit switches in place yet, so I've just put a link for those in the box on the actual machine, so you can actually get the thing working. And then finally I've got the Ethernet cable there, which basically comes out of that, goes up to the socket in the side of the cabinet there, and then on the other side we've got another cable coming out, and that just goes up into the computer up there. And that aerial thing sticking out there is actually how this computer connects to the internet, so you can obviously update things. The Ethernet on this is purely used for the actual board there and nothing else. Here's the connections to one of the stepper drivers. Essentially we've got at the bottom there the power coming in, so ground and plus 48 volts on the yellow. Then we've got the 4 black wires that go to the stepper motor. And then the 3 wires there, orange is basically common, as it says on the side of the thing there. And then we've got the 2 wires for step and direction, and those 3 come from the actual breakout board we just saw. And all 4 of these are the same, obviously it's just a different motor and different connections on the board for those. Here's the setting switches, and I've configured these for the specific motors, which is essentially a 4 amp motor, and then the features at the end there are also selected, so we've got the standby option, so it reduces the power used when the motor is not actually moving. And that one at the end, which is an N34 or NEMA 34, we don't need that option, so that's actually left in the on position in this case, because our motors are NEMA 23. And the pins there, 6, 7, 8 are not used, so it doesn't matter with those. So for the current, it's basically the pin number 1 there, or switch 1 is on, and the others are off. That gives us a drive current of 4 amps. And 4 amps is what these motors are rated to, so that's why we have selected it. And so we're not using the current set terminals there at the top. In theory you could put a resistor there and set the current to something else other than from the switches, but in this case we can get the 4 amp setting just from the switches themselves, no resistor required. Now in the cabinet here I've got the board installed with the sort of bare minimum of connections. There will be quite a lot of other connections on this side and this side for the panel buttons, which are going here. And essentially we've got inputs here, so when you press a switch it will activate one of these inputs to do a certain function. And then we've got a load of outputs on this side, which we use to illuminate the actual buttons as and when necessary. So although the button illumination and the button in the same physical unit, sending a signal to achieve something will be on this side, and then the controller, or basically the computer, will send a signal back to say that yes, something has occurred, or this button is available for use, or whatever else. And so we'll do that at a later time, because at the moment we just want to make sure that the mechanical parts and the motors and things do actually work. We don't actually need the specific controls at the moment. On the back of the emergency stop here, I've just made this minor change here. So originally we're just using the bottom red contact, which is the normally closed one, so it opens when you press the button. And originally we just had it on these 2, but because we're going to have the external ones, we've got the 2 black wires here which come in from outside. So our circuit is between the grey, so it comes on the grey, goes out on one of the black, and we're just using this as basically a thing to join the 2 wires together, not actually using this contact. So in on the grey, through the switch, out on the black to the other 2 things we'll have externally, comes back on the other black, and that just joined onto the grey as we had before. So we're going to have this one and 2 others, and essentially we're just putting all of the contacts in series so that any one of those opening will of course disconnect the power in the manner we've seen in the previous episode. Here's the wiring for the spindle, and this is the terminal box of the inverter, and the spindle is connected to those 4 terminals on the right hand side. So we've basically got U, V and W, which are the 3 wires that go to the motor. It's a 3-phase motor, and then the one on the right is the earth connection, and that's also got that other wire which comes off course from the earth from the power supply. And over on the left there you've got the S and T, which is basically the mains voltage input. Only 2 used because this is a single phase in and a 3-phase out, although you could use this for 3-phase in which case you would just connect the 3 phases to R, S and T, but in the case of this single phase just goes to any 2 of the terminals over on the left. So the U, V and W is basically what goes to the motor. Now if the motor goes in the wrong direction, as in when it says forward on the inverter the motor's going in reverse, then all you need to do is just to swap over any 2 of the U, V and W connections. Doesn't matter which ones, but any pair can be swapped over and then it will go in the other direction, because obviously when it says forward on the inverter you want it to be going in the proper forward or clockwise direction, otherwise it will destroy cutters and plenty of other things besides. Now because that's wired in, we can now actually turn on the spindle and see if it actually works, because up to this point we've got no idea. I mean, obviously there's no reason why it shouldn't work, but of course you never know with anything that's just been supplied as is. So I've put the spindle in the holder there and just tighten that down so it's clamped in position, and see the plug on the top there just comes from the cable. That's just the other end of the cable that goes straight into the inverter, and I've tightened up the nut at the bottom there somewhat so it doesn't go flying off and killing somebody. And now we can actually go to the inverter, power that up, and then we should be able to use the buttons on the front to switch the thing on and off manually. Now we can actually turn this on here, and to do this we're going to have to use the cabinet in the open position with live parts exposed. So all those people with comments from the safety police better get ready, because this is your opportunity to put all those comments in about how dangerous and unsafe this is. So let's just turn on the main power. So that's the fans and whatever there, and we'll just switch in the other supply as well from the buttons on the front, and then hopefully the inverter will switch on. Now there is a delay in turning on for some reason or other, but nevertheless there it is. So that has turned on. Now this inverter was supplied with the spindle, and the deal with that was that the inverter should already be set up to operate this particular spindle, which is a 400 Hz 24,000 RPM model. So we shouldn't have to go and do any programming, although if we do we have got the full instruction manual in English if we needed to do that, so not too bad. But let's just see what gives here. Basically it's saying at the top here power, forward, and the other's not there, that would be reverse. So if we press reverse presumably it would go to the reverse position. We want forward because we don't run spindles in reverse if we can avoid it. And then we've got hertz lit here, so this presumably is the frequency, currently 0. And then we've got amps and ROTT apparently. So it should show the frequency, which for this one say should be between 0 and 400. So if we press run, then it theoretically should start, and we'll turn this knob to the left position, so the slowest speed. So that seems to be non-flashing. Now in theory we can turn this knob. Yep, and the spindle is now rotating at a rather slow speed, and it is going in the correct direction. Now this is the second time I've actually done this, because guess what? Although there's only 3 wires and only 2 possible options, yep, first time we did this it went in the wrong direction. So it's now in the correct direction, and we can turn this up. That's about 80 Hertz there, so that's fairly fast but nowhere near the full speed, so let's just crank it and see how fast it goes. So there we have it, it certainly does work. And you'll notice it's ridiculously loud, and that's because it's an air-cooled spindle, not one of those water-cooled jobs, which allegedly is somewhat quieter. But who cares, because we're not going to be standing here listening to it all day long anyway. So that's that, it seems to work properly. Now of course that was just turning on manually with the controls on the front. Of course in reality it's going to be controlled from the board here, so there will be some additional control wiring, but in terms of the power wiring for that, then that's pretty much it. Now just have a very quick look at the software that's currently installed on this machine. This is Mac 4 or Mark 4 as the actual controller. Not sure how you should pronounce that, but anyway, you think Mac as it presumably is short for machine. Anyway, this is what we've got here. I've only set this up in the most crude of fashion, just basically to get the things working, so of course a lot more configuration will be necessary. And just on it just says e-stop in effect because the things are not actually turned on. I'm not going to turn this on because the spindle makes quite a lot of noise, or the fan in the inverter makes quite a bit of noise. But this will be the software that we're going to be using. And in addition to this particular one, we've also had to install the driver for the actual smooth stepper motion controller board. And there was also a configuration file which came with that breakout board, which was more of a convenience thing really, just so it has all of the inputs and outputs set up without having to go in and do all of those manually. Now we'll see the motors moving in just a moment, and a couple of other bits, but essentially this kind of software is not the sort of thing that you can just install and then use straight away. It's basically a question of installing it, and then there's a lot of configuration that's necessary to set it up for a specific machine. So there's a considerable amount of stuff in here, and we can just have a quick look at the configuration options, and as you can see there, there's a lot of stuff in there which needs configuration or whatever. And then in addition to that, we've also got the configuration for the actual thing itself, as in the motion controller, and that's got a huge pile of stuff which needs configuring in there as well. So certainly the sort of thing which is going to take a considerable amount of time to set up, but thankfully you only have to do that once, basically for a particular machine. Now let's say I've set it up basically just to get the things working, or motors moving, so let's have a look and see how that works. Now before actually running the motors at any kind of moderate speed, then there is an adjustment to make here, and on the side of each of the drivers there's a small adjustment thing. You can see that at the top right of the unit there, and the idea is that you run the motors at a fairly slow speed and then adjust the little thing there to get the minimum amount of vibration. And this of course will vary for each individual motor, as they're all slightly different. So we'll just do that on one of these. Obviously we're going to do the same thing on all four, but we'll just have a look at one of them. So here's the motor, and what we're going to do is just to turn this on, and I'll adjust the adjustment screw there, and hopefully you should hear a change in the tone of the motor. And so the objective here is to get it so it's the sort of quietest or the least amount of vibration. So I've now done all four in the same way, and also tightened up those clamps so they all now actually drive the various axes in the usual way. So now we're going to try moving the various axes around. I'm going to start out at fairly slow speeds and then basically turn up the speed to see how far it will go. And bearing in mind this is only a fairly basic test, this is probably not the optimal configuration for these motors yet, but it gives you some idea of the actual speeds that this thing can move at. And unlike most of the other CNC videos on YouTube, this is actually not sped up at all. This is the actual speed it moves at. I have turned down the volume on a couple of these sections because the y-axis, being having two motors, is fairly loud when it's actually moving. But anyway, the speeds here are the actual speed, so let's have a look. Now that's it for this time, and there's still quite a lot left to do because the spindle, for example, isn't currently connected to the controller, and the idea is that can be connected so that the program you're running can turn the spindle on and off and also adjust the speed of it. And the speed of the spindle is really determined on what kind of tool is installed in it. Obviously some tools need higher speeds than others, typically the smaller diameter ones. And the idea is to have all of that fully automated so you don't have to poke about with the buttons on the front of the inverter. And that's probably a good thing because obviously it's inside the cabinet. And additionally there's going to be a load of other switches to go on the front panel, again, which we'll have a look at in a later video. And then of course there's the software configuration, because at the moment it's only the absolute bare minimum just to get things moving. Certainly that's very far from the optimal setup. And of course once you add extra switches and things, that needs software configuring as well. And of course after that there's actually cutting some components. So quite a lot more to go, but for this time that's all we're going to be looking at. And until next time, thanks for watching.